All right, the trouble with 23 is there's some equations we can set up that are perfectly true and perfectly good equations. We just don't know how to solve them. All right? So, for instance, these are vertical angles. So I can set 2y plus 50 equal to x plus 44. Trouble is, I don't know how to solve an equation with two different variables in it. We could do the same thing with the other pair of vertical angles. We could set that equal to that. I don't know how to solve an equation with two variables in it. Now, there actually is a way to solve a system of two equations with two variables. Okay? That's part of, in the future, the people sitting there where you are now will know how to do that. Okay? But you guys didn't get it in Algebra 1 because we haven't fully got everything covered in the new standards yet, so you probably don't want to do that. The nice thing is, I can avoid it. And even if I knew how to solve that system of two equations with two variables, this is easier. Yeah, these two right here, what do they make? A linear pair. And we have a theorem that says linear pairs are supplementary. And we have a definition that says supplementary angles are two angles whose measures have a sum of 180. So I can make 7x minus 248 plus x plus 44 equal 180. And I can solve that for x. So let's do that. Let's see. Help me out here. What's 7x plus x? And what's negative 248 plus 44? Equals 180. Now I need to add 204 to both sides, right? So what's 180 plus 204? And what's 384 divided by 8? All right? So we've got x. How can we get y? Same idea, right? These two angles here and here are a linear pair. Linear pairs are supplementary. Supplementary angles add up to equal 180. So I can do 2y plus 50 plus 5y minus 17 equals 180. And let's see, what would that be? 7y plus what? What do I get when I add 33? Oh, yeah, subtract 33. Thank you. And what's 147 divided by 7? Are we finished? We're finished. No, who's talking to me? What's bothering you? All right. Let's go back to this. Remember our learning targets? We've got to identify and use these angle pairs. Okay? So what we're using is we're going a combination here of adjacent and supplementary. Those are our linear pairs. Okay? So if I just had this, all right, angle 1 and angle 2 form a linear pair because of the definition of linear pair. All right? Where's the definition of linear pair? There, no. There, no. There, oh, no. Still not found it yet. All right. A pair of adjacent angles with non-common sides that are opposite rays. Well, isn't that what angle 1 and angle 2 are? They're adjacent angles with non-common sides opposite rays. So they're a linear pair. Then we have the theorem that says the angles in a linear pair are supplementary. What does that mean? We have the definition that says supplementary angles are two angles with measures that have a sum of 180. So, since they're a linear pair, then they're supplementary. Since they're supplementary, then their measures add up to 180. And that's what allows me to set up the equation. So I just use the logic to figure out, oh, that means that when I add these measures together, it has to equal 180. Does that help? And we use that kind of thinking a lot in this class, okay? You got to learn to think logically, and sometimes that's not easy, okay? Some of us are kind of born that way, and some of us aren't, but all of us have to work at it to get better at being logical, all right? So know your definitions, know your theorems, and then you've got to put them all together, all right? You've got to. I mean, I can sit up here and say it, but you've got to be able to put all that information together. All right, so what else would you like for me to do? What problem's next? Samantha? 56. 1/3 of a number is 3 more than 1/4 of the same number. What is the number? Let x equal the number. All right, we gotta have variable expressions for our unknowns. So x equals the number. Now, 1/3 of a number. All right, what's 1/3 of x? 1/3 x. Okay, is 3 more than 1/4 the same number? What's 1/4 of x? All right, so our unknowns were the number, 1/3 of that number, and 1/4 of that number. Now let's make our equation. So 1/3 of a number is 1/3 of a number is 3 more than. All right, if you're going to make 3 more than something, are you going to add 3, subtract 3, multiply 3, or divide by 3? You're going to add 3, so it's going to be something plus 3. Or I could do 3 plus something, right? All right, so 3 more than what? 3 more than 1/4 the same number. So the expression on the right side of the equals represents 3 more than 1/4 of the number. Make sense? All right, let's see if we can solve this thing. Everybody ready? Let's clear fractions. What do I multiply by to get rid of those two denominators? I need to get rid of a denominator of 3 and a denominator of 4. 12. Remember the term least common denominator? That's what I need to multiply by. The smallest number that is a multiple of both denominators. Least common multiple. Remember that term. Okay? So the least common multiple of the denominators. So 12, 12. All right, on the left, I can divide 3 by 3 and 12 by 3, so I get 4 times 1 times x, 4x. On the right, distribute that 12, so 12 times 1/4, I can divide the 4 into the 12 and get a 3, so that'll be 1x times 3, which is 3x, and then distribute the 12 times the 3, and 12 times 3 is 36. Subtract 3x from both sides, and that's our number. All right? Yeah. Okay. As long as it's multiple choice, guess and check's fine. If that's not multiple choice, you follow me on the rest of it? Okay. All right. What else you want me to work? Really? Is that it? Hooray.